In the second inverse trigonometric functions example, we are asked to simplify the function sine of cotangent inverse of 3x. Now, just like we did in example 1, we're going to let theta equal cotangent inverse of 3x, because that's really what this does represent. So let's take the cotangent of both sides. Cotangent theta will just equal 3x, since the cotangent and cotangent inverse are inverse functions. Now for our next step, we need to draw the triangle for cotangent theta. So let's say that this is a right angle here, and this is theta. Cotangent theta equals adjacent over opposite. And this is supposed to equal 3x. So just like we did in the last example, we can let the adjacent equal 3x and the opposite equal 1. So since this is the adjacent here, I can let this equal 3x and the opposite can be 1. But really, we're not looking for cotangent theta. We're looking for sine of theta, since this we let be equal to theta. So sine theta in our triangle will equal opposite over hypotenuse. So we need to solve over here. Let's do a little aside and solve for the hypotenuse. Well, we can just use Pythagorean's theorem. So it will be the square root of 3x squared plus 1 squared. So this is going to be equal to the square root of 9x squared plus 1. So let's take this and stick it down here for hypotenuse. So we already know that the opposite is 1, and the hypotenuse is the square root of 9x squared plus 1. So therefore, sine of cotangent inverse of 3x equals 1 over the square root of 9x squared plus 1. And that's the solution. Here's a problem you can try.